Firstly, I think you guys know about the definition of temperature as well, right? Heat is a form of energy. It transfers from body at higher temperature to body at lower temperature. It means higher to lower. Okay, wonderful. We discussed about it later. But right now, we'll discuss about the SI unit first. SI unit of heat, right? SI unit is joule. What? Joule. In short form, it is written as J. And CGS unit is its calorie, right? Calorie in short form CA, right? So coming to the temperature definition, heat is an energy, but energy could be measured by using some quantity. Here, temperature is a quantity. By using this quantity, we are going to measure the energy. Which energy? It is nothing but a heat energy, right? Heat energy could be measured by using the quantity. That quantity we call it as a temperature, but the normal definition is nothing but hotness or coldness of a body. Hotness or coldness of a body is called temperature. For suppose suppose I just place my hand on the board, I tend to feel a little bit colder, right? So I simply say it is colder, right? For suppose I put my hand over a gas stove or something else. Let's consider a gas stove here. Okay, it looks like wonderful item. For suppose if we consider the gas stove is still burning. Now I place my hand on the burning gas. Now what happens? I tend to feel hotter, right? So I simply measured the quantity is whether the quantity is colder or hotter, right? I simply say that's because I simply measured temperature. So it is going to say whether the object is hotter or colder, right? So that is the reason we say temperature is nothing but the measure of heat energy. Okay. Now coming to the SI unit. SI unit of temperature is Kelvin. K. Okay. Coming to the CGS unit. Coming to the CGS units, in internet and many other textbooks also, they have given Kelvin only. Okay, there is no other unit for CGS unit, but in some other textbooks and also in some other materials, they might use degree Fahrenheit sometimes and degree centigrade sometimes. But if you browse in the internet or something else also, they might simply say Kelvin is also the CGS unit for temperature. But in examination, they might ask only SI unit, don't need to confuse about it. Yeah. So temperature SI unit is Kelvin. SI unit of heat energy is joule. Right. Now, if anyone asks you what is the relation between the calorie and a joule, right? So 1 calorie is equal to how many joules? How many joules? 4.186 joules. How many joules? 4.186 joules. In general, it should be written as 4.2 joules. Yeah. So the relation is very simple. 1 calorie is equal to 4.2 joules. Okay. It is much important. Now coming to the temperature. Coming to the temperature, we have 4 types of scales. How many scales we have? 4 scales. Okay. So those 4 scales are very important, but among those 4, 3 are majorly important and the final one is not that important. Firstly, we have a degree centigrade scale, centigrade scale. If we look at the centigrade scale, it is a normal scale that we use in our thermometer. You know about the thermometer, right? So in the thermometer, it might look like this, right? If you look at the diagram, it doesn't look like a thermometer. Okay. You look inside, let's say it might be like this, right? Okay. But here there might be some amount of lines like this, and you can to see some of the values here, like 0, 1, 2, 3, 4, and so on, right? So these kinds of values we tend to see on the thermometer, right? So these values indicate the scale, right? Based on that scale, we easily calculate your temperature. Here, So firstly, centigrade scale, if we consider the scale, let's say this is the low fixed point. It begins with 0 and ends with 100. Which means overall how many divisions? 100 divisions. 0, 1, 2, 3, so on, 100 divisions, right? So in degree centigrade scale, we have a low fixed point, that is 0, and higher fixed point, that is 100. So 0 to 100, and this is the centigrade scale. Now if you consider degree Fahrenheit scale, it's Fahrenheit scale. If you consider the Fahrenheit scale, same measurement, same scale, but this begins with 32. Low fixed point begins with 32 and ends with 212. Ends with 212. So overall 32 and 212. So low fixed point is 32 and higher fixed point is 212. So if you consider fourth scale, that is degree Rheumur. Okay, degree Rheumur scale. Rheumur scale, same thing, but they divided this thing with 0 to 80. It begins with 0 and ends with 80. Right? And finally, we have a Kelvin scale. Okay, don't put degree here. Okay, while writing the Kelvin scale, there is no degree. You don't mention. Okay, so Kelvin scale begins with 273 and ends with 370. Right? Begins with Kelvin scale begins with 273 and ends with 370. Right? So now in examination, they might ask you the problems. Right? The problems were very simple. They might ask us to convert degree centigrade to Kelvin, or else degree centigrade to Fahrenheit, or else Fahrenheit to Rheumur, or Rheumur to Kelvin. Right? So many different kinds of questions might be asked in the examination. Right? Here, okay. Now we'll take the scales, and on the other hand, we'll take the low fixed point and higher fixed point and total number of divisions. Okay. Firstly, we'll take the first scale, that is degree centigrade scale. So degree centigrade scale. Degree centigrade scale, lower fixed point is 0 and higher fixed point is 100. Right? Total number of divisions, 100 minus 0, it's 100 divisions. Right? Wonderful. Next, if you consider next case, that is degree Fahrenheit scale. It begins with 32 and ends with 212. Right? It begins with 32 and ends with 212. So 212 minus 32, it's 180. Right? In third case, degree Rheumur. Right? So degree Rheumur scale begins with 0 and ends with 80. Overall, 80 minus 0, 80 divisions. And finally, Kelvin scale. Kelvin scale begins with 273 and ends with 373. Okay, 373 minus 273, it's 100. Right? If you consider these two, first thing and the last thing. Okay, if you consider these two, total number of divisions were 100. Right? So the distance that had taken from here to here is the same, right? Yes or no? Same distance, but 4 persons divided the same distance into different ways, right? So degree centigrade divided it into 100 divisions, and it also divided into 100 divisions, Kelvin also, right? But these two were relevant, right? Here in this case, degree Fahrenheit divided into 180 parts, but this thing is divided into 80 parts, right? So if we consider these two, what happens is, in our textbook they had given us 0 degrees centigrade is equals to 273 Kelvin, right? Which means degree centigrade is equal to Kelvin. Is it true? Is it true? No, it's not true. But they had given us 0 degree centigrade is equal to 273 Kelvin, which means what happens here is, it begins with 0, right? Degree centigrade begins with 0, and there is 1 after 2, right? So 0 to 1, there is a space, right? right, if we consider the space. And also if we consider other scale, that is Kelvin scale also, it begins with 273, it begins with 274, right. So if we consider the space between 0 to 1 and 273 to 274, the space that is formed in between these two is the same. The space is same but not the actual values. Clear? Exact game in this case you tend to find 0 to 1. The space is there here, right? This space and the space between 273 to 274, these two were same. So that is the reason they had given us 0 degree centigrade is equal to 273 Kelvin, but don't tell it to anyone that degree centigrade is equal to Kelvin. It's not a right answer, but the right answer is 0 degree centigrade is equal to 273 Kelvin. Clear? So now they might ask you several questions based on these things, that is they might ask us to convert from degree centigrade to Fahrenheit or Fahrenheit to Kelvin, right. So we'll form a equation here. Let's say we'll start with the symbol C, minus lower fixed point. C minus lower fixed point is 0 divided by number of divisions 100, okay, equals next value. Fahrenheit scale begins with F minus lower fixed point 32 and number of divisions 180. Okay, let's do it. Third case also, symbol R, lower fixed point 0 divided by number of divisions 80 is equals, finally Kelvin scale K minus lower fixed point is 273 divided by total number of divisions were 100, right. So let's say, now just simplify this, simply remove zeros here. C by 100 is equals to F minus 32 by 100, sorry 180 is equals to R by 80 is equals to K minus 273 by 100. Okay, I think these denominator values might get cancelled in 20 table, right. So in 20 table 100 goes for 5 times, in 20 table 180 goes for 9 times, 80 goes for 4 times and 100 goes for 5 times, right. So the final equation and the final formula is C by 5 is equals to F minus 32 by 9 is equals to R by 4 is equals to K minus 273 by 5. Okay, this is the required formula. Okay, this is the required formula to convert from one degree to another. Okay, one scale to another scale. So this formula is mainly used to convert from one scale to the another scales, right. So let's do it further. So the formula is C by 5 is equals to F minus 32 by 9 is equals to R by 4 is equals to K minus 273 by 5, right. So this is the formula, right. Now they had given us a value, let's say 20 degrees centigrade is equals to how many Kelvin, right. They had asked us this question. Now we need to find C by 5 here, degree centigrade relation, and K relation is here, right. You need to take these two relations right now. So let's substitute the value. C by 5 is equals to K minus 273 by 5, right. So here 5 and 5 got cancelled out. What will remain? C is equals to K minus 273, right. So C value are already given, right. C value is 20 degrees centigrade. So 20 is equals to K minus 273, right. So here 273 is subtracting K value, right. Now I just wanted to send this to the other side. What happens? It becomes a plus. 20 plus 273 is equals to K. Overall, if we add, we'll get a value of 293 Kelvin, which means 20 degrees centigrade is equals to 293 Kelvin, right. So but in our textbook we had a logic, simple logic, that is while you are converting from degree centigrade to Kelvin, you simply add 273 to it, right. Or else we are converting from Kelvin to degree centigrade, just subtract 273, that's it, right. Or suppose if you consider we are converting to degree centigrade to Kelvin, right. So they had given us 20. 20 plus 273. Final value is 293. Same answer that we got here, right? Yeah, it's very simple. While you're converting from degrees centigrade to Kelvin, you need to add. For suppose 293 Kelvin is there. 293 Kelvin. You need to convert into degrees centigrade. Just subtract the value. How much? You need to subtract minus 273. It's 20 again. We got the same value, right? Yes or no? We just started with 20. We got the same value, right? So sometimes you might find little bit this thing a little bit difficult. That is exactly in the examination hall, right? While you're sitting inside, you got it out. That is whether you need to add or subtract, right? You will get that doubt, right? So to rectify that doubt, you simply remember this formula. The formula is very simple, right? The formula is C by 5 is equals to F minus 32 by 9 is equals to R by 4 is equals to K minus 273 by 5, right? Clear? So let's say, let's do one more sum. Let's say we'll just convert centigrade to Fahrenheit now, right? So healthy human body temperature in degrees centigrade is 37 degrees centigrade is the healthy human body temperature, right? So what is the healthy human body temperature in degree Fahrenheit? Okay, they might had asked us this question. So you need to take the relation between these two, that is C by 5 and F minus 32 by 9. The relation is very simple. C by 5 is equals to F minus 32 by 9, right? I think they had given us the value. What is the value? 37 in place of C, I just substitute 37 by 5 is equals to F minus 32 by 9, right? So simply do the division here. In 5 table, 37 goes for 5 is 25, 5 6 is 30 and 5 7 is 35. We got 2 here, put a point and put a 0. In 5 table 20 goes for 4 times. 4 5 is 20, it's 0. So the value is 7.4 is equals to F minus 32 by 9. If you consider 9 is dividing, if we send 9 to the other side, what happens? It is going to multiply, right? 7.4 into 9 is equal to F minus 32, right? So let's multiply these two. Okay, let's ignore point first, then we'll add on in the answer. 9 4s are 36, 7 9s are 63 plus 3 66, right? We have only one point here. Let's put 66.6, right? It is 66.6 is equals to F minus 32. Okay, here 32 is subtracting. We are going to send this value to the other side. Now what might happen is 66.6 plus 32 equals to F. If we add on, we'll get 60 plus 30 is 90, 96 plus 2. It is 98.6 degree Fahrenheit. This is the healthy human body temperature in degree Fahrenheit scale. Now you guys got two important questions here. Question is, what is the healthy human body temperature? That too in degree centigrade. 37 degrees centigrade. What is the healthy human body temperature in degree Fahrenheit scale? That is 98.6 degrees Fahrenheit. Clear? I think you got these two. Right? Wonderful. Right now, let's say, now try to convert this value. 40 degrees centigrade is equals to dash degree Fahrenheit, this value, and 50 degrees centigrade is equal to dash degree Rheumur, and 293 Kelvin is equals to dash degree Fahrenheit, right? So try to solve these sums and write the answer in the comment section below. Thank you.